I'm Robert Hollis, CEO and founder of Asilium Research, and today we'll be taking a deep dive into some myths that are related to AI security integration, specifically what off-the-shelf AI security scanners are not telling you. This is extremely important because right now there is a lot of recent product developments and also just generalized increases in adoption of AI integration within many security organizations in different industries. So being able to spot questionable or concerning type of offerings is important to be able to discern from what's real and what's not. So starting out, AI security tooling is not a magic bullet. It is not a one size fits all. It is not a, hey, buy my product, drop it into your solution, and then magically all problems go away. A lot of people want to try to sell you that. That is not the case. All right, so it's only as useful as the context that it receives, the workflows it integrates into, and the expertise guiding its output. So we still have some concepts of human in the loop here. We still have the experts guiding the output. We still have a lot of tooling that has experts in the loop providing additional context to those tools, right? Nothing wrong with that. It's just we need to really understand that it is not a magic bullet as of yet. This could change in 6 months. I make no promises. But currently, it is not a magic bullet. There is definitely still some human in the loop within the vulnerability research or security testing, not just with vulnerability research. It could be with threat detections, it could be with remediation guidance. All of those different areas of the security organization could be PCERT teams, could be vulnerability management. You still need experts in the loop. And some examples that we're going to be talking about today during this presentation are going to be detection quality varies heavily by vulnerability class. This is important to understand the high level. Remediation requires product and business context. A lot of these AI tooling orchestration systems or AI harnesses essentially is what a lot of these AI security scanner products are. Their orchestration, their harnesses, they're lacking the proper business and product context. Some of them offer the capability for the end user to be able to provide their own context to improve the output and reliability of their tooling. That's totally fine. Another example is going to be generic scanners often create noise, not security outcomes. And this is important to be able to understand that, hey, once again, AI is here, agentic workflows are here, automation's possible, but we still need to be able to avoid the same pitfalls of classical sense when it comes to security scanning and not repeating those same pitfalls, right? So not creating a lot of noise for the business. We don't want scanners that create 50,000 vulnerabilities and then we quickly realize we don't have enough people who can actually validate those. Or let's just go full AI right now. What if we have AI systems that are fully validating all 50,000 vulnerabilities, but they're not properly being able to apply the proper business logic, code logic, or any of that type of logic and context in a proper manner so that the remediation guidance it provides doesn't just reintroduce more vulnerabilities potentially in the future. Right now there's a lot of fatigue with engineering, so we have to not only think from a security perspective, but from an engineering perspective. And we'll cover that later on in this talk. Why there's still that relation between engineering and security. So starting out, we have this issue where AI finds all vulnerability types equally well. This is partially true, but not entirely, right? So the reality is that different vulnerability classes are not equally represented in training data, benchmarks, or scanner logic, right? So you could have, let's say, in a magical world, we have an AI model that comes out. There was a whole bunch of public data it was trained on. A lot of that public data heavily favored SQL injection type of vulnerabilities. Well, if it's able to have a large corpus or training set of data that's heavily related to SQL injection, but very limited amount of maybe more memory corruption focused type of vulnerabilities or flaws, then that model will be able to easily identify which wider ranges, right, of SQL injection within your products rather than being able to equally find as many memory corruption within your product. So we have to also take into account that we have different types of vulnerability classes. You have time of check, time of use, toctile, race conditions. You have multi-step exploit chain logic. You have business logic flaws. You have insecure authentication and access controls. There are ways that you can take the existing frontier models and build your orchestration and harness so that you're able to kind of patch some of the lack of that knowledge. But that comes back into your context, right, that we talked about in the previous slides. The context that goes into the orchestration really is going to dictate the quality of the output. Next is that if it found the bug once, it will always find it, right? Well, I hear a lot of people talking about this where you have like deterministic or repeatable output. This is a big question the past couple of months now that a lot of clients have been talking about is that, hey, if we implement this, how deterministic is it going to be that, it found a SQL injection on the first run, but is every single run after that going to find the same SQL injection? It's extremely hard to say, right? And currently right now, there is probably no company that can guarantee 100% it's going to find on every single run the exact same vulnerability repeated over and over and over with a 100% guaranteed success rate. The reason for this is because these are non-deterministic systems, right? There's a lot that goes into building your harness and building your orchestration that tries to validate the type of code that it's analyzing for vulnerabilities. So like a prime example is like PR commits. There's a lot of products out there that offer the ability to integrate into the PR system, review every single PR, look at it from a security perspective, try to gather additional code context and understand the product to then be able to ascertain like, hey, is there a vulnerability here? What type of vulnerability? And how do we actually fix this into a package, right? So they offer that. Having that run repeatedly over and over and over and over, finding the exact same flaw, giving the exact same feedback is kind of hit or miss. You might get a lucky streak where you have 10, 15, 20 runs, it works, but then you have that one run where it just completely for some reason, the models just don't put two and two together, right? So that does happen. They have the same code bases on the same day, 3 scans, and you can very well get 3 different results sets. So this is kind of more of a question of, okay, well, if we're deploying AI and we're thinking about how we want to integrate it into our business, this gets real cost heavy, right? Because if you're running 10, 20, 30, 50, 100 tests, it's all autonomous, right? The price for that starts to skyrocket really quickly. So one way around this is diving into local models. At that point, you can pretty much just run the test as much as you want without really worrying about token costs. But that's for a different type of topic. Next is going to be more findings means better security, right? So I really don't like this at all. And not even before like AI security or AI integrations. I never liked this whole mantra within InfoSec community or industry where more vulnerabilities found equals, hey, this product is more secure. It's very rarely the true statement, right? Like finding vulnerabilities is not the hard part. Understanding why the vulnerability exists and how do we actually solve this problem, that is the hard part, and that is the part that gives you real meaningful protection for the future, right? So like if we take the classical approach where we're just finding a bunch of vulnerabilities, we deduplicate some of them. So like if you have a bug bounty program with a PCERT team, they're probably being ambushed with hundreds of reports right now that are heavily AI assisted, which is not the greatest outcome, but they're having to deduplicate a lot of these findings, understand, okay, which of these are actually exploitable, how do we prioritize these, and then which of those actually end up getting fixed in this next version sprint, right? So it could be that you have in this example, 1,200 vulnerabilities. After a duplication and trying to figure out how many of those are actually unique, you end up with 640. Out of those 640 reported vulnerabilities or findings, you then realize, okay, 85 of these are exploitable as of right now. You then have to go through, assign like a severity score, threat models, risk assessments to figure out which ones you want to prioritize first. And then that leads into the final, which is 14 that actually get fixed during this version sprint for the product. This is a very common thing, right? So we have to, and this falls back to like classical scanners as well, where like, hey, like we're going to find and alert you with 20,000 alerts of all these different vulnerabilities and all these highly critical, exploitable vulnerabilities in your environment. But there's really no way for you to be able to sit there and be like, okay, like we have a team of 20, 30, 40 engineers. How are they going to work their way through 30,000 reports, right, or potential findings? Extremely difficult. And it actually leads to security fatigue, which then just leads into this feedback cycle where your team actually ends up missing the important vulnerabilities because they're so fatigued from having to go through all the other reports that and this is kind of like a personal hope, in the future for the infosec industry, we can avoid those type of situations with AI adoption. Like I do not want to see the industry repeat the same mistakes as before. Like people hyper focus, and a lot of times I think it's more so the security practitioners. I think it's the security firms, the people who are selling you products and consulting that look at ways to provide value to a business. And a lot of times it's almost negative in a way, right? Because if the amount of vulnerabilities you're finding, okay, you find 10,000 vulnerabilities. What do we do now? So like the vulnerabilities are not the main focus. It's everything after that that's kind of the hard part, right? So that I really wanted to spend a little bit more time on this slide, but it's very important. The next myth is that AI understands your application, right? A lot of people are like, hey, just, buy my product, put it into your environment, and then all of a sudden, it's going to find every single 0 day. It's going to write all these exploits, and your product's going to be super secure, and it's going to cost you like $1,000. I'm just making up a price point as an example. But the reality here is that most tools see code fragments, not the actual product. And also, like, one interesting question during your procurement cycle when you're looking at acquiring an AI type of product for security, for like scanning, for example, for vulnerabilities in your code, ask them how do they validate the thought logic and audibility and visibility of how a vulnerability is discovered, right? So how are they tracking what code was read that led to a discovery of a specific vulnerability? How are those arguments and variables tracked throughout the life cycle of that vulnerability, right? So they should be able to answer those questions. Whatever product you're buying should be able to tell you exactly how they're doing that. And if they don't, I would classify that as a red flag, right? Because at the end of the day, if you have no way to be able to observe, like, hey, how is this AI security product taking into account authentication roles and scopes? How is it looking at data sensitivity, feature flags, internal service calls? How's it looking at business logic? Like, how is it mapping all of this together to build that context awareness that it needs so that it can properly apply remediation or that security mindset to some degree to be actually effective and valuable for the business? Now, there are some easy wins as frontier models continue to increase and improve in their capabilities. There's less and less harnessing and orchestration you need, is what we're actually seeing currently. So 6 months ago, you needed a decent amount of harnessing and orchestration. A year ago, you needed a lot more. Nowadays, people are one-shotting vulnerabilities by just prompting Claude or Codex inside of like a loop, and happy days. But As of right now, if you're still trying to understand, like, hey, does AI actually understand your entire application? You need to ask those companies that you're looking at acquiring their products, like, how are they handling visibility? How are they handling chain of thought? How are they handling reasoning? Are we allowed to observe this and see those steps that it took, right? Is it applying root cause analysis? Is it doing automatic variance analysis? Those things all matter. Next is going to be context is easy to automate. I love this one. this is a this is like the biggest well, I wouldn't say the biggest one, but I definitely love this claim here that it's easy to get the context you need. The reality is that it's easy to ingest context, right? But the harder part is being able to ingest the correct context in the proper manner to make the AI security system actually useful, right? So, at what stage within your orchestration harness do you look at managing the context of code ownership, architecture diagrams? How do you handle secrets and config patterns? How do you integrate historical vulnerabilities for variant analysis, right? So what about secure coding standards? There could be past triage decisions for certain vulnerabilities that the business had and made. And how is that integrated and ingested as part of the context for the AI security system? That those are all very important topics that, just applying AI to something doesn't actually solve these problems. Like if you just use AI and say, hey, Claude, Codex, Copilot, find vulnerabilities, secure my product, it might come back with things that look interesting, right? But how do you actually validate that, hey, it's adhering to our secure coding standards? What about these triage decisions that were made in the past for certain types of vulnerabilities? What about previous vulnerabilities like variant analysis? Is it thinking about those? API contracts. What about previous threat models you performed? A lot of tools that are being created now are trying to adopt a lot of this into their product. But then again, a lot of them are also making it so that the end user has to provide all this information to improve the output of the AI system, right? Which is totally fine. It's not a bad thing. It's just something to be aware of, that if people are saying that, like, hey, context is easy to automate, I would see that as a potential red flag. Next is going to be generic remediation is good enough, right? So if you just say like, hey, sanitize this user input, that's very vague, right? And we want to try to avoid that as much as possible, because we have to think about not only the security engineers. So if you're running your own security organization, you have PCERT, you have your internal security engineers running tests, you have different departments of security engineers, you have like networks, product, architecture. They're all working in their own little silos doing their work. So, and at enterprise scale, I mean, this could get very daunting very quickly, even for very senior individuals, right? So the less that we have to make them actually work through and think and spend hours and hours trying to come up with a solution, right? The better overall it is for the business, as long as the output from the AI agentic system is context aware. Do you see the picture here now? Like we've been talking about context the last slide. Now we're moving into the remediation, and we have to make sure that in order to get good remediation advice out, we have to make sure that the context we provide is ample. Some examples we see on the slide here. Generic fixes, may break existing behavior compatibility. Can introduce new untested risk, right? That could be due to lack of context. The same problems that we face with non-AI systems, like it's in a general enterprise environment, you could have engineers. Maybe this engineer who's working on this report within PCERT isn't aware of this newly documented architectural diagram for this product, and they're going to make a decision. That decision could cause new issues in the future. Why is that? Because they don't have context of that new architectural diagram, the design diagram. That same problem surfaces in agentic systems, right? So the context aware fix could be that the remediation actually matches the framework, architecture, and coding standards for your division or your business. Verifies against existing behavior before merge. That could be that you have a stand-up environment where you get to build and deploy your application, do regression testing, sort of. This is going to be more testing compatibility of the remediation advice. So it could be auto-generated a fix. Let's deploy that and test to make sure it actually works and doesn't break anything else along the way. So this is an important step, right? Next is going to be AI replaces security engineers. This is a tricky one, right? Because I think even though we've seen a lot of advancements with AI adoption in security and other industries as well, but for cybersecurity, currently there is still a need for human judgment. You might be able to reduce the overall headcount for your organization because you have the ability to automate a lot of the analysis. But at the same time, you still need a handful of actual human in the loop operations so that they can apply judgment to some of the output while we're still in these early stages of AI adoption. I know it seems like you look around and everyone's talking about AI this, AI that. You know, they've achieved X type of metric, or you know, their teams have achieved XYZ, and you know, now they're taking over the moon. Just remember that, like, it doesn't matter what everyone else is doing with your org. It just matters, you know, what you're doing and what you're trying to achieve to better the security for your organization. That's all that matters. Don't compare yourself to all these other companies. Just focus on you, your lane, what you're trying to achieve, and how you're going to do it in a secure manner that's actually beneficial for the business long term. So I would say that the early stages of threat modeling, you can use AI for that, but there's still going to be a human reviewing the output. Exploitability validation. You might not need a human to sit there and spin up every single environment, configure all the proper software that needs to be on the system, the product, configure the environment to match what deployed looks like, and then test the vulnerability to see if it's actually exploitable. That can all be performed by an autonomous system, but there's still going to be a human reviewing the output to say yes or no, like, yeah, this is clearly a vulnerability, it's a working exploit, we've achieved X capability, we need to fix this. Root cause analysis, that can be heavily automated, but still you're going to, at the end of the day, you're going to also have a human who's going to be reviewing the output. These are kind of like human level guardrails, right? So like a lot of the automation happens, but you still have that human in the loop factor that we need to take into account. Next is going to be the secure design review. Yes, you can use AI to assist with this, but like every other stage before this, there's still going to be a human reviewing the output. And finally, risk acceptance. I see for the foreseeable future, there's going to be a human that's tied to the risk acceptance of any type of security issue that's presented due to the fact of responsibility and accountability. So you have to ask yourself who's going to be responsible and who's going to be accountable for, you know, why this vulnerability was not fixed. It's hard to do that to an AI bot. You can't. It's really, I laugh, but it is a tough area of business, right? Like, how do you basically remove all human level judgment and just assume trust in this fully autonomous system that's going to make the best decisions? We still might be away from that future where everything's fully autonomous. So in the meantime, and this is just one workflow of an example. This could be like a PCER team who's working on incoming vulnerability. This applies to many different areas of security. So next is going to be the plug and play integration is enough. I see this everywhere, right? You go look at LinkedIn, everybody is selling their AI chatbots or their AI security tool or autonomous penetration testing, which is great. Personally, I think it's awesome. Innovation with new technology, it's really, 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 really good. But very few of them are actually talking about how are they actually doing this work. Like how are they engineering their products to support proper CI/CD integration, to handle code ownership. How do they touch an engine, like relate to engineering SLAs, retesting and verification? How are they handling all these things, right? So you see on LinkedIn, you go look it up, search it, AI security scanner. They're gonna be like, hey, buy my tool, all these great things, but everything we've talked about in this presentation so far, I would ask them those questions. You know, can you tell me how this vulnerability was found, the chain of reasoning and thought, what type of context was provided for this decision to be made? All of those matter, right? Because if you don't have that visibility, then you're at the mercy of whatever is happening on the other side behind the curtain, right? And in security, we don't want that. You do not want to just blindly be accepting this thing works as it's advertised, right? That is far from the truth. Next is going to be benchmarks prove production readiness. Um, yeah, this is a big one. Everybody benchmarks a lot of their tools off of how many 0 days can they find against different projects. Which is great. I love the seeing that AI is being used to find 0 days in different products and all of this amazing stuff. But you have to ask yourself, okay, this is cool, like you're finding 0 days, but how is it actually hardening the overall security posture for this product, right? Like what's actually being solved here? You find vulnerabilities, you find 0 days, cool, high five, we all celebrate. But from an actual security perspective, and this might be a bigger viewpoint than just AI. This is probably the history of like security or cybersecurity, but finding a 0 day or finding vulnerabilities has never been the difficult part. It never has. Going back and understanding, okay, how do we get the business to understand that, hey, we sell a product, and how do we actually understand the true root cause of why this vulnerability class exists, and start addressing that. That's an extremely costly adventure, right? So it's not cheap. So it's easier to just, play whack-a-mole, right? So you get a bunch of vulnerabilities coming in, all these 0 days are flying around everywhere. But at the end of the day, if you ask yourself, well, is it more secure or no? Because every week there's a new 0 day. So then that begs the question of like, does it really matter? Big question. But let's be honest here. Let's think about this. If every week there's a new Windows kernel 0 day, there's a new Mac kernel exploit, there's some WordPress exploit going around, are these systems actually more secure? Or can we just assume that, hey, everything's insecure and we need to rethink the overall strategy of all security? It's a big question. I probably don't know the answer to this one, but just some random thoughts during the presentation. It's early morning. I got some coffee with me. These are some real realities, right? Because as a business, like I said, early morning, there's my alarm. Let's get back to the presentation though. So like benchmarks prove production readiness. Everybody can benchmark something and get a nice output. Say, hey, look at all these vulnerabilities we found over and over and over. But then, when it comes to reality, you're going to have legacy code, partial migrations, within actual products. You're going to have generated in third-party code, undocumented shifting assumptions by teams, developers, engineers. I mean, there could be multiple frameworks they're testing out at one time. Like, there could be a lot happening behind the scenes, and you have to be able to take all of that into account with whatever AI integration you're doing, or if you're buying a product or integrating it yourself. That's extremely critical, right? So next is going to be buying the tool solves the problem. This is big, right? And here's the thing too. In today's world, CISOs are seeing a lot of pressure. I've seen talks of there being discussions around what happens in the world where CISOs are legally, tied to security breaches within an organization. So then the true nature side of all this is that if you operate purely from the perspective of just, hey, I do cybersecurity, happy days, but you don't think about the actual business driving factors, you could get sidelined pretty quick within the industry. So we have to remember that buying tools solves the problem. It sounds good in nature, yes. And for offloading responsibility, it could work in your favor if the tool you're purchasing absorbs all of the responsibility for any type of vulnerability that gets found or used to breach your company. Right? Make them accountable. Remove the liability from yourself onto whatever product you're buying. Now, that's a big statement, but I think you would actually start seeing a change in the security industry if third-party security companies, product sellers were actually held responsible for the fact that a company got breached because of, things they missed. And we could see a big shift. But let's step back to this, right? So the reality is that buying the tool doesn't actually solve the problem. It only solves one layer. So you have the context engineering, the secure data pipelines. That then leads into like custom prompts and retrievals, finding validation, remediation playbooks, product specific rules, feedback loops, metrics tied to risk reduction. That all gets packaged in there and used with the AI model at each stage, right? So it's like start 1, 2, 3, just go down the list. It's all interacting with the AI models inside of some integration system. Buying the tool doesn't solve for how your environment's set up, right? It doesn't magically know, like, we use this version of this framework, or we're not worried about this type of vulnerability because of X reason in our release builds, right? The tool isn't natively going to know that. You're going to have to provide that context. So we pretty much covered a whole bunch of different topics during this presentation. We're at about 33 minutes into this. But the takeaway from this is like what actually looks good from a security product, or if you're trying to build your own internal security automation, just trying to figure out how do you architect this and actually integrate it so that it works within your organization. So the first thing you want to talk about is product aware. That comes down to the next topic, which is going to be context, right? As much context you can provide for your product, the better the output. You want it to be repeatable. This is tricky. It's hard. If you're using frontier models and you're paying token costs, they could get very expensive running thousands of tests. If you're using local models, that could be an upfront cost, one-time upfront cost, but you're also going to have, depending if you don't have data centers, you're going to have to pay the data centers, you're going to have to pay hosting fees for all the hardware you acquired, all of that. So it's a larger initial upfront cost, but then you're saving money, I guess, long term, depending if these token costs start going astronomical, $200 for output per million tokens. I'm just guessing here. um, you want your system to be triage aware. This example here, we're talking about, PCERT. It's a pretty straightforward process. You want it to be able to understand how do you build the product, how do you do the actual testing, how do you hook up a debugger, how do you provide the payloads, how do you record the system state output to determine, hey, was this actually exploited or not? Is it still vulnerable or not? That's what you want integrated. Relying purely upon a code scanner is only a partial answer. You want verifiable proof that the vulnerability no longer exists. That's how you get the second half, and I have a video talking about that previously on the YouTube channel. You then have exploitability focused. That ties into the triage. Then you want to integrate it into engineering workflows, CI/CD pipelines. You can have it tied into your existing SaaS and DaaS solutions. And then continuously improve from historical findings. So you want a feedback loop that's then taking previously found vulnerabilities, applying variance analysis and other additional context to future runs. So to finally cap this off, just remember that don't buy magic, build capability. Start with a focused assessment. Identify where generic tooling creates noise, where context is missing, and where custom AI automation can reduce real risk. Right? That's important. And that's what we offer here at Obsidian Research. We don't promise you magic bullets. We don't promise you all problems will be magically solved. Instead, we're looking at understanding that, hey, every client's environment is different. Every client's products are different. Their needs are different. How about we come in there, work with them and understanding, hey, what are their current pain points when it comes to AI adoption, how to adopt AI properly within the organization to improve the life of the engineers, not only from security, but from the product engineer perspective as well. So basically, it would be a focused assessment, hop on a call, talk for probably an hour, free assessments, and then that leads into the next step of where exactly is the context breaking down, and that's a big part, right? So without further ado though, I am Robert Hawes, CEO and founder of Basilium Research. This is a 37-minute video. Appreciate you listening, and if you're curious about how we can help, feel free to reach out. Bye.